instead of me just standing up here and lecturing you for an hour, you guys are going to be doing the notes in your groups. So we're starting chapter 3, which is all about, so we'll start with parallel, perpendicular, and skew lines. Then you're going to learn about angle measure or angle pairs. And then we're going to learn about the special things of congruence that happen with them in this one section. And then after that, the next section is proofs with that stuff. And then after that, it's just transformation. So the rotations, reflections, composition, transformations, all stuff like that, and symmetry. This is a pretty short chapter. I know it doesn't look like it by the packet, but if you look through the packet, 90% of that packet is pictures. That's why it's so thick. So, the way this is going to work is you're going to work in your groups to do this. Talk, work together, figure it out. I'm going to walk around and kind of try and guide your thinking if I notice it's getting a little off. But other than that, you're completely on your own. We're going to start. We're going to stop after each page. I'm going to set a timer, depending on which page it is. Depends on how much time. You'll have the timer up here. And that'll be how much time you've got to finish that page. And we'll go over the key things from that page, make sure everybody's on the same wavelength there. So, looking at this first page, I'm going to do the first box with you to kind of show how this works. The first thing we've got, you can see the perpendicular line. Now, we've already talked about perpendicular lines in the last chapter. Does anybody know what the definition of a perpendicular line is?
Lines that form a 90-degree angle.
Yeah, so that's good. So lines that form a right angle, lines that intersect. Now, I like that definition, but I want to be a little bit more specific. So let's look at the examples that they gave us. They give us UT, this line right here, and VT, this line right here. So what do we notice that those two lines share, obvious, besides the intersection point? What else? What is the relation in space? Let's think about it that way. They form a 90-degree angle, that's how they're perpendicular, but think about it in a 3D aspect. So say you've got a cube. What?
They share a side of the cube.
Share a side of the cube, but what's another way to say a side in geometry?
They're adjacent.
No.
By
What's another word for a side?
Linear.
horizontal base.
Let me find.
I can't think.
Okay, let's look at,
Face, maybe?
here, we'll look at this. Look at this. All right, imagine this is a cube. I know it's a rectangle, but imagine it's a cube. What do we call one side of this?
A side.
What's another word for it?
Face.
A face, okay?
Of some.
Think about the very first chapter we talked about. What would we call that?
Plane.
A plane.
Oh.
So, the key thing from that definition is we need to add that they're on the same plane. When you make these definitions in your groups, I want you to be as specific as possible, especially when it comes to relation of the plane that they're on. Because you're going to see in one of these definitions that makes a difference. So do we all kind of understand what you're doing for this first page? All right, I'm going to give you 10 minutes to do the first page in your groups. So go ahead and talk, work in your groups. I'll put the timer up on the board. You guys can be talk and be loud. It's okay. I'll let you know.
For example, X, Y, and X, W. And I would see
There's
the B is already on there.
I'm gonna say X.
You have a 22.
about what we have at perpendicular.
Sides of
But you look at more specific. Let's look at what we have at.
They all go the same direction.
Think about what we have at here.
They go in the same direction.
Same. Same, right, but what is it? Keyword. That's the keyword.
Hold on, man. Figure out. I'm looking ready now. Yeah, put my.
The quick check.
Very much.
If it's parallel planes, that means multiple different
It's just planes that don't touch.
planes, so nothing else. Just that.
Yeah, that's all you do.
Oh, yeah. Hey, but we have to do three, so we're getting behind.
What should we do for like the examples? Like,
I got Y, Z.
do we draw or do we just write?
You're gonna use the cube.
No, what was the other one? No, I.
Where's skill line?
Oh, that was. Oh, no, that was
Quick check.
Oh, I see.
Like, as in, like,
I know, I was, that helps. Never angle. Three more.
yeah, for sure.
Well, wouldn't the claim be made
Did you just turn? What? So there's nobody 14. That's what. Or I don't. So you're supposed to be in. You're supposed to be in. Wait, no. So. I don't know. He's tired. Okay. It'll be 18 in 8 days. I won't be here for my birthday. I would have had the stats.
We can reuse.
Tell me, don't just make your birthday.
I know, I just thought of it. I would have put my face on that. I already got my birthday gift from Wisconsin. Maybe something or and she was like, oh, I'm gonna do something. She let me draw on the face. I'm gonna eat my face. Why? That's not fun.
It's not nice.
XYS, you said? Hey, I won't, hey, I'm not gonna, hey, listen. I will not call you. Okay, is it a order there for us?
Oh, that's what you add this.
We're just doing the front page, right?
Yeah.
Okay, so.
So you're done with the front seat, so it's starting back.
I don't know, some hold up.
Okay, 3 minutes.
I have no idea. Okay.
What's up?
This is like, you heard the end. Oh, wait, look, you did.
I'm gonna take my head. Would HB be parallel? Parallel? Never touch BC.
Yes,
HB. I put HB and HB. Is HB right? Okay, cool. No. I was asking. I had already written down. I already written them down. So.
Okay.
All right, you've got about 2.5 minutes left to finish the front page.
Do you want to see this?
Yeah, go ahead.
Because they're all.
So, look at the first page.
Oh, wait.
What would
I
you
don't
call
know,
it?
this one. I know it is. I'm gonna write it like every day.
So what page? Yeah.
Oh, this is, okay.
Oh, yes,
Listen to music. I need to find music. What's on my set? And actually, the only things I have for my birthday are Will Smith, Miami, and Pitbull. All songs by Pitbull.
What would you call
On the weekend. You should listen to that song.
So you say that they all parallel or not?
Yeah. After hours. I have hotel room service at the home.
But they're both like that way.
I have shoot myself. Miami,
So
I keep writing it down.
and Chancellor.
No, they do it.
I don't know what else. So I'm just
Oh, it really said they don't.
Especially look at the first one.
You've never been taught like what?
Just like they recorded it.
I think
So
so.
I'm not sure.
I like climbing.
Let's finish this.
I say Steve Body.
So what changes? Okay. Nope,
Yeah, it was a child mom. It was two. My mom. When the mom was on.
Yes. How dare you be on
All right, time's up.
Yeah, you were.
Let's go through some of this.
No, actually,
Okay, all right. Oh, wait a second.
Guys, quiet.
All right, let's go through this. So somebody give me the definition for parallel lines.
Lines that never touch on the same plane.
Yes. The lines that never touch. On the same plane. So, let's kind of visualize these. I'm sure most of you have an understanding of what parallel is. So let's say there's a line in each one of the corners of the ring. So if we're looking at this line here and the line right up here, are they parallel? So if we're looking at the line from where the wall meets the ceiling and where the wall meets the floor, are those parallel lines?
Yes.
Okay? What about this line on this wall and that line on that wall? Are they parallel? No, they're not, because they're going to intersect at that corner. What about the line from that side of the ceiling to this side of the floor? Are they? Yes, they are. They may not be on this. You may not see the plane, but there is technically a plane between those two lines. So we kind of understand that?
Yep.
How do we feel? Good? All right. So then what about parallel planes? What do we think the definition of a parallel plane is going to be?
Sides that never touch.
Planes that never touch. All right. Now we're through what you guys have probably been familiar with. So let's look at the next one. We've got skew lines. So, somebody give me their definition for skew. Yeah.
Lines that are not parallel on different planes and do not intersect.
Yes. Exactly. Lines that are not parallel. Do not intersect. And are on different planes. Yes, they break all the rules. All right. So now we've seen the new definition of skew lines, as well as we've reviewed perpendicular and parallel. Thumbs up, thumbs down. How do we feel about this so far?
I don't
Good.
get it.
Okay, well, we'll get a little bit more practice with it on the next page. So if you flip that page over.
What about the practice thing?
I'm not going to go over that right now.
Oh, come on, I did good on that.
You should see two diagrams that look like this. You've got a rectangle. I think that's a rectangle. I don't think that's a cube. And then you've got this crazy looking pentagonal prism. Don't get hung up on the name. Not that big of a deal. So, I'm going to give you 5 minutes. Focus on the bottom one first. Get that one done first, and if you get done with that, then move to the top. But do the bottom one first. Do the crazy looking one first. That's the one we're going to go over.
Isn't that what is that?
It's a pentagonal prism. You've got 5 minutes. Go ahead and start.
Would NS be related to RQ? Oh, no, I'm talking about RQ. So, that'd be very low. Now,
I can't lie about that.
not parallel, just you, so JK and RK. Like, but JO, RQ, not the same side, not the same like, such a friend. Wait, is this?
Yeah, don't take, don't bring up, yeah.
Okay.
A lot of visitors.
That's what I say. And you said.
Yeah, I think I did it right.
Got about 40 seconds left. All right. Let's look at this one. The first question asks us to name all segments parallel to RQ. So remember, to be parallel, they cannot intersect and they need to be on the same plane. So RQ, what segments are parallel to those? What do we got? Yeah. ML. Yeah, you got ML. Do we have any more? No, we don't. What about segments parallel to KP? Yeah, LQ. What else?
JO,
JO.
MR,
Which one?
MR,
Yeah. MR
and NS.
and NS. Because they'll never intersect. Now name a plane parallel to SRO. Yeah. So how do we name a plane? We first write the word plane, then we can use 3 points. So N, M, J. You also could have said M and L, K, L, J, whatever you wanted to put, as long as it was on that plane. Now somebody give me a segment skew to JO.
RQ,
Yeah, we got RQ.
SR, SN, and QP.
Are you sure about SM though? Because remember they
Oh wait,
can't
no,
be
that's parallel, never mind, yeah.
We got PQ. Yep, that would work. PQ, and then which one? KL. I think there's more than just those 4, but you only need to name 4. All right. Are there any questions on this? All right, now move to the next page. All right, so your next page should look like this. You're going to do the same thing you did on the front page. So you're working your groups to complete this. This one probably won't take you all that long, but really quick. If you look at the bottom of this first page, I think it's about, yeah. For these, give me 8 pairs. Don't give me all of them. That's so much to write in such a little space. Just give me 8 of each. All right, you have 10 minutes to complete this page. Go ahead and start.
Oh, I have to. Wait, didn't they ask you? He's asking how many
I don't need to sign out tomorrow. Yeah. I'm tired today.
That only comes you should be excited for a math class.
I am excited. That is like my favorite now.
See?
I love math.
See?
Like my first 2 years of math were like kind of terrible, but then after that, like I got exact crazy, and then I got you guys. You guys are like terrible.
Thanks, I appreciate that.
I don't enjoy the time consumption of it, but I enjoy solving the problem.
Yeah.
If that makes sense. Miss Face even emailed me back.
Might be busy right now. Probably. Maybe taking care of stuff that you need to go to classes. I do fix a computer this morning.
First, you just like school Wi-Fi was terrible. What?
Yeah, that's.
Oh, man. How many did you see for each? The Oh my God. He literally said, don't do all of these, just do 8 of them. So that's still a lot. This is the point. Okay, listen. We've got 9. So they're only
Welcome back.
I
I need to start drinking more water. I feel very unhealthy.
It sounds like an answer. So I.
Is these
What is it? Yeah. You're smart.
Let's see. I'm so cold. You're cold. It is still cold. You don't have to prepare. I can do
Okay. Not always.
At first I was really hot. Well, what? There's 1, 2, 3, 4. Why did I even mark this? Okay, so that would be this one.
No. Try it.
Same side of the transfer. So you got 2 and 6. That's your example.
1 and 5.
Yep. Go make sure you got it the same way. Every angle from
And then 8 and 6.
Yeah.
It's the one up on the
I'm so cold.
No, you
No, there isn't. Two and 6 are corresponding to 3 and 7 corresponding to 1 and
Alright. So then alternate answers.
Yeah, of course it is. That's why I don't get it.
An alternate upstairs.
7, 6, 2, and 8.
Yep.
Stop singing a while.
Why?
Because I want to figure it out myself.
I really want to roll it right now. No, I already emailed her. I don't want to see
I read so late, I forgot what it was. No, it's my foot now.
I'm so cold that I'm itching, you know what I mean?
She's cheating in my paper.
I like the brace.
No, I did not.
This one. We can go, figure out ones, and then if you're not.
Alright.
God, freshman Ringo was a dude.
Alright, so how many angles are formed when a transversal intersects 2 lines?
What?
Yeah, there's 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 angles. So So then corresponding angles, these are going to be our angle pair types. It's going to be very important when it comes to what we're going to learn next. So the first one is corresponding angles. Those are angles on the same side of the transversal and in the same position. So if we look at the example they give us 2 and 6. You see they're both on that same side of the transversal and in the same position in relation to the line. So what's another example?
Angle 1 and angle 5.
Yeah, we got angle 1 and angle 5.
Angle 4 and angle 8.
Angle 4 and angle 8.
Angle 3 and angle 7.
Angle 3 and angle 7. All right. What about my alternate interior angles? We've got 3 and 5. So interior angles are going to be on the in between the two lines. And then alternate means they're going to be on opposite sides of the transversal.
4 and 6.
Yeah, we got 3 and 5. So the other one would be 4 and 6. Now the exterior. Those are going to be on the outside of the two lines. And they're going to be alternate. So they're going to be on opposite sides of the transversal. So they give us 1 and 7. The other one is 2 and 8. All right, and then we've got the same side. I know you can't see it on the board, but it's on your paper. The same side interior angles, they give us 3 and 6. So those are interior, remember, are going to be in between the two lines. But this time we're going to be looking on the same side of the line. So we got angle 4 and angle 5. All right. So these pairs are going to be very important when it comes to when the two lines that transversal intersects become parallel. So you're going to need your Chromebooks out. Please get your Chromebooks out. I believe it'll work. It may work on your phone. It's been kind of iffy.
What are we playing?
You're doing a
Well, I don't want
kind
to
of a
see
discovery.
I love you, kid.
I hate it so much.
It's not a good thing.
Why did I
It's hard, like in general. I feel like in any other subject.
I hate this so much. It's so stupid.
I
I hate it.
All right. So once you get into that, once you get into your Chromebooks, you're going to type in this URL. It's up at the top of the next page. I'll give you a minute to get to that URL. Once everybody's there, give me your eyes up on the board. Oh, I know you're done. And I can start explaining. So you should be on the back of the next page. And you should have typed in that URL. If you don't have a Chromebook or it's not working on your phone, and there's somebody else in your group that does have the Chromebook or it's working on their phone, just work with them, make sure you can see it. All right. So when you look at this, when you go to the link, it should look something like. Oh, sorry. It should look something like this. So you're gonna look at the diagram that's right underneath the question. Identify what type of angles those are in terms of the pair. And then you can select which one it is. After that, after you know what pair it is, that's when your paper is going to come in handy. So you see there's a postulate and 3 theorems. You're going to try and complete those theorems based on what you notice from the figures, so you can actually move A around and see what happens to the angles. So I'm going to give you 6 minutes to complete that box. Don't go on any farther yet, because I want to do the next stuff together. So go ahead and work on that. Try and finish the theorem. You've got 6 minutes. I will put the timer back up on the board. No.
I'm just gonna click all over. There's more questions. What is that's your life. It says
How is this not? So it's 2 right answers. I don't understand. Oh, really? That's usually
I don't know why it displays that. There's no way to change it.
no.
If you select it as one, that just told you.
That's, you know, that's really.
This is select something like this.
Right now. It's changing.
So it wasn't stop. That's how you look at it.
Oh. I got it. What? You're the same. That means you get the I'm telling you, so. They go and do
Oh, the angle here. Three, 3.1 is our homework. Let's not move on to that.
It says homework, you dumb idiot.
This, Shelby.
He said that's if you walk out.
What's another word
I love my profile. I've added some freshmen. It's one of David Dobrik's problems. The one who gets like canceled all the time.
Yeah.
But like he wasn't like getting canceled in like freshman. So you know what? I'm gonna make it. And he's gonna have
All right. Let's look at this GeoGebra.
I know, but I'm not laughing for my birthday. That's what I get for my birthday. It's my birthday. I'm gonna be 18.
All right. So, what kind of angles are these? They're corresponding. And then what do we notice about the angles as I move A?
They stay the same.
They stay the same. What's another word for that in geometry? Congruent. So in that blank with the corresponding angles postulate, it says that if two parallel lines are cut by a transversal, then the corresponding angles are blank. In that blank, you're going to write congruent.
How did you know my birthday?
We can all look at it.
Huh?
We can all see birthdays.
You can all see where we live too.
Yeah. What pair is this? These are alternate interior angles. So, we have an alternate interior angles theorem. It says that if two parallel lines are cut by a transversal, then the alternate interiors are blank. What do we notice as I move this about the angle measures? They're congruent, so we're going to write congruent in that blank. What kind of angles are these? These are alternate exterior angles. So the alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the alternate exterior angles are blank. What happens if I move A? They stay the same or congruent.
Are they all congruent?
No, they're not all congruent.
What was the first one?
They're congruent.
Oh, okay.
For zero.
No, it's probably gonna be supplementary.
All right.
Not supplementary, I forgot the word.
No,
Something like that.
Not complimentary.
you might be right.
Wait,
All right. What kind of angles are these? They are same side interior. If two parallel lines are cut by a transversal, then the same side interior angles are blank. I'm going to move this to a random thing. What do you notice about them? They're not congruent, right?
Not congruent.
No, that's not what you're writing. So if they're not equal to each other, what's our next instinct to do to them?
They can be equal to each other.
No, if they don't equal each other,
They can be equal together.
you're not going to make them equal to each other.
Add them together.
You're going to add them
I
together.
said that.
What does that add to? Take your calculator. If it's just your phone, I don't care. Add it together. It's 180.
Linear.
I literally told you guys.
You're so sorry.
So what is the other word for adding to 180?
Supplementary. What
Supplementary.
did I tell you guys?
So when two parallel lines are cut by a transversal, the same side interior angles are supplementary. That's what you're going to write in the blank.
It's my birthday.
All right. Let's look at this middle box here. So we're given two lines with a transversal and measure of angle 1 and angle 2. What angle pair is shown here? They're corresponding. Now it says that if the measure of angle 1 is 48, is the measure of angle 2 48? Why or why not? I want you to talk in your groups. I'm going to give you a minute. Talk in your groups. Come up with a reason.
No.
And come up with a solution or an answer.
Maybe it's a restaurant, right?
Yeah.
I got distracted by Yeah. Did you say that there, if you use this, it's still the same? Parallel. So.
All right. Show of hands. Who says that the measure of angle 2 is 48 degrees? Raise your hand.
They're parallel. Never come.
Why is the, if they're not 48 degrees, raise your hand. Okay, somebody give me a reason why they're not 48 degrees.
Because the two lines are not parallel.
The two lines are not parallel. That is the key word from all of those definitions, is the lines have to be parallel.
I put this here not on the same transversal. It's still wrong.
Yeah, so the lines have to be parallel. Because they're all the same transverse.
What's French?
Transverse is the one. Looks like these ones. All right. So let's look at this example right here. So this one. If I wanted to find out what the measure of angle 7 is, somebody tell me what the measure of angle 7 is. Why?
Because they're
Why is it 113?
They're a vertical pair.
There are vertical angles. They are vertical angles, and vertical angles are congruent. What about the measure of angle 6? What's the measure of angle 6?
130. No.
67.
Yeah. 67, and then
67 degrees.
8 would be.
Why did you get 67? How do you know that the measure of angle 6 is 67 degrees?
113 and 6, or measure 6 and angle 113 are they're on the same line, so they're supplementary, so they add to 180.
Yep. They're a linear pair, so they add to 180. All right, what about? What about the measure of angle 1? So the measure of angle 1 is also 113. Why? Yeah.
Because they're parallel. They're two exterior angles.
What's the name for it?
I don't know. Wait, corresponding. Wait, what? Yeah.
So you're looking at 1 and 7. Or, well, yeah, you can. Yeah, they're corresponding because they're corresponding. Sorry. What about the measure of angle 2?
2 would be 67.
67. All right. Now let's do these two. I'm going to give you a minute in your groups. 1 minute. Complete these two examples right here. And we'll talk about it.
If you want to show 80 miles,
I was very far off. Why do you hurt yourself? Who's a ring that you
Look at your computer, my money.
Where are you going?
Davis. Here's the grade. Mine's gray. This is black. What color is this? Gray. A dark gray. Silver, black.
Alright.
Gray and silver.
What's the measure of angle 5?
71.
Why?
Because they are
They're vertical.
vertical.
They're linear, supplementary.
They're opposite. They're opposite.
They're corresponding angles.
Yeah, that's what it's called.
Measure of angle 4 is 62 degrees. What's the measure of angle 6?
118.
Why?
They're all same side interior angles.
They're same side interiors. All right. Now we're going to move on to these. So let's look at this first example here. We'll do this one together. So we're looking at this one. So we need to find the values of x and y. So, first things first, what do we want to do? I like where you're going, but let's push that back one.
So 3y plus 26 equals 64 degrees.
No, plus 64 degrees, because then equals.
Oh yeah, plus, and then it would equal 180, yeah.
Yeah, so let's go ahead and find y first. So if we use the 64 that they gave us, so we've got 3y plus 26 plus 64 and set it equal to 180 because that's a linear pair and they're supplementary. We can find our y. So when we solve this, we're going to combine the like terms first. So we've got 3y. What's 26 plus 64? 90. And we got 180. We're going to subtract 90 from both sides. We're going to divide by 3. What's 90 divided by 3? 30. So we've got 30 for y. Now, there's a couple different ways you could go from here. We could go with our first method, which was going to be to set them equal to each other, because now we know y, and we can plug it in. Or you can just go ahead and plug in the y, and whatever y gives you for that one, are those angle measures going to be the same?
Wouldn't 64 be the same as the other side of the?
Right here.
Yeah.
Yeah, that would also be
Okay.
64.
I'm just double checking.
So, if we just plug in for y, what's it going to give us for the measure of this angle? So if we plug in 30 for y,
116.
so we get 116. So we can set x. We can set this angle here equal to 116. And what's that going to give us? So we're going to subtract 11 from both sides. What's 105 divided by 7?
15.
Everybody else get 15. What did you get?
I didn't get anything, but I think that would make the most sense. It works. I guess I
That was so much unnecessary work just to get one on the back.
It was very nice.
Yeah, you could have just, but you have to find, it's asking you to find x and y. That's all we're trying to find. So what do you get for x?
15.
Is it 15?
Yeah,
Yeah.
15 years.
I never heard a confirmation back. All right, do 11.
The second one.
I'm gonna give you 2 minutes. Do 11, find x and y.
Yeah, except for mine is always dead.
All right. So, how do I find x?
5x minus 30 equals 135.
Yeah, we're going to set it equal to 135. So 5x minus 30 equals 135. Why can we do that?
Because they're corresponding.
They're corresponding angles, which means they're congruent, so we can set them equal. Now we can add 30 to both sides. We're left with 5x equals 165. Divide by 5 on both sides. And what's that going to give you for x?
30.
Everybody else in 33?
Yeah.
All right. Now how do we find y?
It's a right. Well, no, because it's there's not a square.
By the way, equals 90,
How do you know it equals 90?
because there's the right angle.
Oh yeah, there's the box down the bottom. Yeah.
It's a right angle.
Okay.
So
Hey, I need everybody to listen up. This is important.
With the same side interior angle and 190 degrees, so it was
So what are same side interiors? What are they to each other? Are they congruent, supplementary?
supplementary.
All right. So same side interior angles are supplementary, right? Which means they add up to 180 degrees. So what's 180 minus our known 90? 90. That's why we can set 9y equal to 90.
Teachers, I need Evan Binky, Henry Bennett, John Kirkland, Jessica Lane, Jacob McFerrin, Ethan Miller, Jamie Miller, Hayden Shy, Carly Steinert, Owen Umpley, and Gabriella Underwood to the main office, please. Oh, and Logan Wood.
All right, so our y is going to be 10. Your homework is the next page in the back of that page. I will post the key on Classroom.